An 8.8 magnitude earthquake struck the heart of the Pacific Ocean, hitting Russia's strategic zone directly. Tsunamis spread across the entire Ring of Fire. Millions were forced to evacuate, military bases were flooded, and a volcano erupted just one day later. This is the strongest seismic event in the region since 1952. Although the epicenter is over 4,000 kilometers from China, experts say this is not an isolated incident. It may trigger a chain of geological reactions reaching deep into the interior of Asia, especially in fault zones accumulating high pressure, including areas in central inland China. Could this be a geological domino effect, quietly starting a new doomsday cycle? According to official data from the Russian Institute of Geophysics and the International Seismic Monitoring System, the earthquake occurred at 3:47 UTC on July 30, 2025, with a depth of approximately 1920 kilometers. The epicenter was located about 119 km southeast of the city of Petropavlovsk-Kamchatsky, in the offshore Pacific region, where the Pacific Plate directly meets the Okhotsk Plate, an extension of the North American Plate. Right after the main tremor, sea level monitoring devices recorded abnormal waves along the Kuril Islands. Water levels rose unusually high, up to 5 meters in Severo-Kurilsk, flooding coastal infrastructure and Russian military facilities on the Kuril archipelago. In Hawaii and Japan, tsunami waves reached between 1 and 1.7 meters, enough to force authorities to freeze multiple transportation routes, cancel flights, halt trains, and suspend port operations. Warnings were issued to more than 10 countries and territories, including the United States, Peru, Chile, New Zealand, French Polynesia, and other Pacific Island nations. Japan issued an emergency evacuation order for nearly 2 million coastal residents in less than 3 hours after the first alert. Chile conducted a large-scale evacuation, relocating over 1.4 million people from coastal areas. Peru closed 65 seaports. The U.S. raised the tsunami alert level for Alaskan waters, later downgrading it as the threat diminished. At the earthquake's epicenter, daily operations were severely disrupted. However, images from the scene showed the professional response of Russian medical teams. At a hospital near Petropavlovsk-Kamchatsky, a surgical team continued an open-heart operation while the ground was shaking. They were awarded medals by the government for what was called upholding humanitarian principles amid disaster. Less than 24 hours after the quake, Kluchevskoye volcano, one of Asia's tallest and most active, unexpectedly erupted. Lava flows and ash plumes rose thousands of meters, affecting several domestic and international flight routes from Russia's Far East region. Many geologists believe the earthquake may have shifted the magma pressure inside the volcano, triggering the sudden eruption. This phenomenon illustrates a complex chain reaction between geological energy layers, from tremors to tsunamis, followed by volcanic activity, all of which can occur almost simultaneously if conditions reach a critical threshold. The event also demonstrated that global warning systems, such as the Pacific Tsunami Warning Center (PTWC) based in Hawaii, functioned effectively. However, many international experts agree that maintaining such systems requires secured budgets, proper equipment, and independent monitoring. Even a small budget cut could lead to global consequences. From a geopolitical perspective, the earthquake has set a precedent. A nation with major military capacity like Russia can still face localized paralysis if a seismic event strikes strategically sensitive points. Naval bases, information hubs, and weapons facilities in Russia's Far East region are all located near the affected area. Though no incidents occurred, and this remains data that must be seriously assessed at the regional defense level. To understand why Kamchatka is the epicenter of devastating earthquakes in history, one must look deep into the world's geological map. This peninsula lies on the Kuril-Kamchatka subduction trench, where the Pacific Plate, the fastest-moving oceanic tectonic plate on Earth, constantly slides beneath the Okhotsk Plate, an extension of the North American Plate, at an average speed of nearly 86 mm per year. This ranks among the fastest anywhere on the planet. At such speeds, collision energy builds up steadily over decades. When the strain exceeds the elastic threshold of materials at the trench base, the energy is suddenly released, in the form of a massive earthquake. Because of this mechanism, Kamchatka has historically been the site of multiple megathrust earthquakes in modern times. Geological records show at least 3 quakes in this area reached 9.0 magnitude or higher in 1737, 1841, and most recently in 1952, which was also accompanied by a tsunami that caused severe damage across Pacific Islands. Now exactly 73 years later, the July 30th, 2025 earthquake, with a magnitude of 8.8, has drawn scientific attention due to its alignment with a long-term seismic cycle. Reports from the Russian Institute of Geophysics indicate the Kuril-Kamchatka region is entering a new phase of heightened activity. This trench system stretches over 2,200 kilometers from the southern part of the Kamchatka Peninsula to the northern region of Japan. It is a zone with a high density of active volcanoes, more than 160 volcanoes, many of which remain active. Frequent seismic activity averaging 5 to 7 earthquakes per year with magnitudes over 6.5 on the Richter scale. It's no coincidence that seismologists refer to Kamchatka as one of the most tectonically pressured regions on Earth. Any shift here, even a small one, can affect the entire interconnected tectonic system extending to Japan, the Philippines, Alaska, and even inland China. It's important to understand that not all earthquake energy disperses into the sea. A portion of the seismic waves, especially deep penetrating waves, can travel inland, passing through the Okhotsk Plate and reaching as far as the Eurasian Plate. This force trajectory points directly toward northern and central China, areas already marked by long-standing geological faults under stress. Therefore, the true danger lies at the endpoints where energy accumulates. This is why geological scientists in China, Japan, and the US are closely monitoring regions like northeastern China, the Sichuan Plateau, and especially the Three Gorges Dam area, along the midsection of the Yangtze River. Right after the first sensors detected seismic waves in the Kamchatka Sea, the Pacific Tsunami Warning Center, PTWC in Hawaii, immediately issued early alerts not only to U.S. territories, but also to many nations across the Pacific Rim. This alert network is operated by a consortium of national and regional centers using seismic data satellites and ocean buoys that measure sea levels across the ocean. As a result, within less than 30 minutes of the earthquake, tsunami warnings were issued in over 10 countries from Japan and South Korea to Peru, Chile, and New Zealand. Millions of people were evacuated in time. This system is considered the first line of defense in reducing casualties during global-scale emergencies. However, recent reports show that PTWC's operational budget is facing cutbacks, especially in the aftermath of the COVID-19 pandemic. Some undersea sensor systems have deteriorated and no longer receive routine maintenance. Meanwhile, many small Pacific nations lack the capacity to build their own monitoring networks and rely entirely on warnings from PTWC or parallel systems run by Japan and the US. If these central hubs weaken, the risk of disasters going unreported in time will rise significantly. Another concern is the level of data sharing and cooperation among countries. In reality, not all nations are willing to release sensitive seismic data, partly for security reasons and partly due to a lack of open data sharing mechanisms. This leads to a situation where disaster response becomes fragmented along administrative borders, while geological phenomena themselves follow no such lines. Therefore, international organizations have emphasized the message responding to large-scale natural disasters cannot be solely a domestic responsibility. It requires establishing regional cooperation channels, especially among nations located on the Pacific Ring of Fire, where 90% of the world's earthquakes and volcanic eruptions occur. Beyond its global impact, the Kamchatka event has left a particularly strong echo across Inner Asia, specifically in China, a country with a complex network of ancient fault lines and critical infrastructure vulnerable to propagating seismic waves. Could the tremor in Russia's Far East trigger a resonance effect, reaching the midstream Yangtze region, where the Three Gorges Dam is located. That question will be explored in the next section, where we break down the link between intraplate fault zones and the potential for remote-triggered seismic activity. The 8.8 magnitude offshore earthquake near Kamchatka not only caused immediate effects for Pacific coastal nations. Its impact, as many geologists have warned, may extend far beyond the epicenter via deep underground seismic wave transmission. And one of the countries placed under specific alert is China, home to a series of dormant intraplate fault systems that have remained quiet for decades, yet are always susceptible to being reactivated by distant shocks. In terms of tectonic structure, China sits between two massive, ever-moving land blocks: the Pacific Plate from the east constantly pushing into the continent, and the Indian Plate from the southwest continuing to uplift the Tibetan Plateau at nearly 40 millimeters per year. Under this dual pressure, central and northeastern China, though not located directly on a subduction zone, are in fact zones of converging stress where minor plates like the Yangtze Plate, Amurian Plate, and North China Plate are stretched, shifted, or compressed by centuries of accumulation. The danger lies in the fact that these intraplate faults do not release energy in a regular pattern like those in coastal regions. They accumulate stress silently over many cycles, and a single trigger, even from afar, can break their fragile balance. According to research published in the journal Earthquake Research Advances, this phenomenon has been observed in historic events such as the 1976 Tangshan earthquake, which followed a series of strong quakes in Japan and Alaska, and the 2008 Sichuan earthquake, which occurred during a period of heightened activity along the Ring of Fire in 2007. These cases suggest that interplate resonance is real and could repeat itself if conditions reach the threshold. Areas currently considered potential hotspots include the Lanzhou-Shaanxi fault, the zone of the historic Tangshan earthquake, which has yet to show signs of energy release; the Sichuan-Wenchuan fault, where the Tibetan Plateau collides with the Yangtze Block, marked by a complex seismic history; and especially the Qianjiang fault in Hubei, the bedrock zone of the Three Gorges Dam. Although not prominent on global seismic maps like subduction trenches, these faults lie within ancient rock layers that have undergone multiple episodes of deformation and fragmentation and may now be weakened by long-term weathering. That's why when distant seismic waves like those from Kamchatka travel through the Earth and encounter bedrock types that transmit waves efficiently, such as shale layers, sedimentary rock, or fractured granite, even mild tremors can resonate and become locally amplified. This is the key point, raising concern among many geologists. It's not that seismic energy from Kamchatka is strong enough to trigger earthquakes in China, but that China's geological foundation has the potential to self-activate if jolted at the right time and intensity. Hidden fault lines could be awakened, and in a worst-case scenario, those vibrations could reach the midsection of the Yangtze River, where the Three Gorges Dam is already under another pressure, rising reservoir levels during the rainy season. On administrative maps, China and Russia seem far apart, but underground, their fault lines are connected. Some researchers warn that if unfavorable geological resonance occurs, tremors from Russia's Far East could propagate to the mid-Yangtze region, where the Three Gorges Dam is currently operating at high capacity. The Three Gorges Dam is the largest hydroelectric structure in the world. Spanning over 2.3 kilometers and rising 185 meters high, the dam is built on ancient bedrock in western Hubei. This area intersects with the Qianjiang Fault Zone, an underground tectonic structure beneath the reservoir that stretches in a northeast-southwest direction. It had already been flagged as highly sensitive to activation if subjected to resonant vibrations from distant seismic waves or increased local pressure. The danger lies in the combination of three risk factors. Seismic waves traveling underground could activate microcracks in the dam's foundation, especially at joints between non-uniform rock masses. Landslides or rockfalls from upstream, previously recorded in 2010, and 2013, Greece. 20 could fall directly into the reservoir, generating backflow waves that hit the dam from within. Peak water pressure in the reservoir increases permeability, causing underground erosion, especially in weathered rock layers or zones with pre-existing tectonic fractures. If these three factors occur in a short span of time, when seismic activity and water pressure act simultaneously, it may create stronger vibrations than usual. In such cases, small fissures in the foundation may widen, and pressure from the reservoir could penetrate weak rock layers, triggering minor displacements. Though not enough to destroy the main structure, this could reduce dam stability, lead to base erosion, inner reservoir backflow waves, or upstream landslides. In fact, since the reservoir was first fully filled in 2010, several landslides have been recorded around its shores, some auxiliary embankment sections have developed cracks, and the seismic monitoring system had to add new measurement points. In a worst-case scenario, if emergency flood discharge is required to relieve pressure, the downstream Yangtze River, including densely populated cities like Wuhan, Nanjing, and Shanghai, would face a major risk of widespread flooding. Notably, no publicly disclosed independent or specialized aftershock monitoring mechanism currently exists at the dam's foundation. This means monitoring minor structural shifts, which could serve as early warning signals, relies almost entirely on internal operation units. Given the recent uptick in seismic activity around the Pacific Ring of Fire, this represents a strategic blind spot that must be re-evaluated seriously. So are China's fault lines entering a new phase of activity after decades of silence. Let's revisit the historical cycle of megathrust earthquakes both around the Pacific and deep within the Asian interior, to examine whether the 2025 Kamchatka quake is truly the first signal of a new seismic chain reaction. One aspect often overlooked by the public but closely studied by geologists is the cyclical nature of tectonic activity. Although earthquakes seem sudden and unpredictable over geological timescales measured in centuries, certain patterns still emerge. And the seismic sequence connected to the Kamchatka region is a thought-provoking example. History shows that the region's largest earthquakes, such as those in 1737, 1841, and 1952, occurred roughly 90 to 110 years apart with minimal deviation. The 1952 quake, with a magnitude of 9.0, is regarded as a historic megathrust event that triggered a widespread tsunami across Pacific shores. Notably, the July 30, 2025, Kamchatka earthquake, measuring 8.8 in magnitude, struck exactly 73 years later, suggesting a shorter cycle and indicating that the Kuril-Kamchatka subduction zone may now be entering a more active seismic phase. Looking more broadly, this cycle does not seem confined to Kamchatka alone, but shows a noteworthy overlap with deep-seated disturbances within inland China. The 1976 Tangshan earthquake's 7.6 magnitude occurred 24 years after the 1952 Kamchatka megaquake, and geologists from the University of Tokyo and the China Earthquake Administration have analyzed it as potentially linked to energy shifts from the Pacific Ring of Fire. Similarly, the 2008 Sichuan earthquake's 7.9 magnitude followed a period of intense seismic activity stretching from Sumatra to Japan. These timelines indicate that deep intraplate faults within continental interiors are not entirely independent, but may react in sequence following major seismic events at plate boundaries. Beyond energy transmission, another concept deserves attention. Geological force following a major earthquake can transfer to other regions, triggering subsequent quakes. When a large earthquake strikes, energy is not only released at the epicenter, it also restructures the stress balance in surrounding zones, even those thousands of kilometers away. In this model, if there are fault lines already near the activation threshold, the redistribution of stress may be enough to push them past it, leading to secondary quakes like dominoes falling in a system. According to data from the China Earthquake Network Center, within just 48 hours of the 2025 Kamchatka quake, a series of minor aftershocks magnitude 4.5-5.1 were recorded in Jilin, Hebei, and Sichuan regions, with well-documented seismic histories. Though not damaging, these tremors are signals that the system is reacting, and seismic energy is beginning to shift deeper into the continent. The earthquake in Kamchatka signals that a new tectonic cycle may be taking shape along the Pacific Rim. Far from being limited to Russia's coastline, the shockwaves have penetrated deep into inland Asia, activating initial tremors along faults that had remained dormant for decades. Several regions in northern and central China, including the reservoir area of the Three Gorges Dam, have begun reporting unusual geological shifts. Meanwhile, water levels in the reservoir remain high with no public updates to the alert system. Could a small distant resonance be enough to rupture the already stretched equilibrium beneath one of Asia's most strategic infrastructures? Share your thoughts in the comments. In a world that's constantly changing, your perspective could be a crucial piece in understanding what lies ahead. Thank you for watching. If you found this content helpful, please like, subscribe, and share the video to help spread the message to more people.